Lily Gerard, a professional data analyst at the University of Kansas, has been absolutely instrumental in guiding the analytical approaches used in this project. She has been my primary analytical partner for the last several years, and we plan to continue this collaboration for years to come. However, there have been more than a dozen other statisticians and data analysts that have been involved in this project, and each and every one of them was extremely willing to assist. It seems likely that a similar response would be received from any university statistics department. With this bank of knowledge available, it seems silly not to take advantage of their willingness. Once the data is entered and converted to the necessary format, send it to your analytical partner and let them play with the data. It's all zeros and ones in their language. It makes no difference to them what the variables are. The interpretation of the results is obviously up to the knowledgeable researcher. But because the visual information has been rendered in this binary manner, this allows for an extremely wide range of analysis types to be applied to the data. There are quite a number that have shown great potential for the analysis of visual material. Some of these are very complex, such as factor, cluster, and correspondence analysis. However, one of the most basic is also one of the most informative: correlation. Simply put, correlation means when you tend to see, or not see, one variable, the other variable tends to appear or not appear in likewise fashion. Rain and umbrellas are highly correlated, while rain and sunglasses, which rarely occur together, have a strong negative correlation. Correlation is not about causation, however. These studies only reveal the patterns apparent in the data, not the reasons behind those patterns. As for comprehending some of the more complex forms of analyses, a single semester of targeted statistics and data analysis training would provide a very strong basis for performing analyses using the dominant software tools in modern statistical research. After reading a few books, with no formal background, I was able to perform and comprehend many different types of analyses using these tools. However, unless you have the desire to perform these analyses on your own, it is much better to be able to give the data set to a professional analyst and then simply read the results. It is fascinating that in this process combining the trained eye with the data analyst, many of the same patterns are discernible to both. When Lily and I went over the initial results from a factor analysis that she had performed, she was surprised that I was able to group many of the variables in ways that were reflected by the statistical results just from my familiarity with the material. The key point of this approach is to let the data lead you. Allow the statistical tools to provide instant access to all of the patterns apparent in the target dataset, and then, with the trained eye, choose a pattern to focus on for research. This method is analogous to the use of a metal detector. It doesn't guarantee that you will find anything, it just dramatically speeds up your search. Most often, a metal detector lets you know, you don't need to dig here, and this methodology is similar. Even when a pattern is evident, this process does not tell you why it appears. It is up to the researcher to determine if it is worth investigating, and if so, to search for the significance behind it. Some identified patterns need no investigation. For example, while there is a very strong positive correlation between horses and battle scenes, this is wholly expected to the trained eye and requires no further attention. While there are pitfalls with this method for the untrained, there are established ways of dealing with them. For instance, in order to provide a coherent group of similar records for statistical analysis, it is vital to separate out rich records that may provide artificial weight. For example, if you were doing an average income study for the zip code where Bill Gates lives, you might want to remove him from the dataset to avoid the confusion in the results that would come from the wild deviation from the norm that he represents. In this project, it was realized that the 120 offering scenes appearing on the pillars in the second courtyard at Medina Taboo had to be separated to avoid skewing the results for the wall scenes. This group, being so rich in a particular scene type, overwhelmed the variations discovered in the wall scenes and produced problematic results. Likewise, poor groupings, such as a homeless person in Bill Gates' neighborhood, would also produce artificial weight and pull the data. Although patterns of attribute usage showing distinct, consistent tendencies are of great interest, sometimes it's the outliers, those places where the usual patterns do not hold true, that are the most fascinating. An outlier can be viewed as a deliberate choice, whereas a consistent pattern would represent a more automatic or subconscious usage. A modern example of an outlier would be sunglasses being worn at night, a rarity that does occur, such as by media stars within the context of a red carpet event. In studying these strange nighttime occurrences, a researcher would note that the sunglasses in this context serve a dual purpose of providing protection to the wearer, disguising their eye movements and shielding them from the glare of flash, while projecting a particular constructed image to their worshippers. The red carpet represents a venue where no one else can tread, and the stars are providing a public appearance, separate from the other contexts, such as in their limo or within the event, where they are not visible to their fans. Similarly, in the case study performed for my dissertation, outliers in the quantifiable patterns for the grouping of 5 regalia elements I was focused on pointed out the highly unusual nature of the royal costume in 4 particular scenes of the processing king found in the corners of the first courtyard. In each of these scenes, Ramses is depicted wearing completely different headgear, but much of the rest of the costume and other attributes are nearly identical. The statistical analysis made it quite clear that all 5 attributes have very strong negative correlations with several of the other elements of regalia that appear in these depictions, such as most of the headgear and the type of staff the king carries. The data also showed that these 5 elements appear all together very rarely. Within the current database of nearly 1,000 records, they are combined only 6 times. Examinations into the many other combinations in which these 5 attributes appear revealed subtle usage patterns for the various pairings and groupings that were connected to the types of scenes they were used in. Through this effort, it became clear that these elements of regalia were related to different interconnected roles the king was expected to fulfill. When combined together, they projected a constructed image of ideal kingship that was quite appropriate for the context of the corners of the first courtyard of the king's memorial temple. With the dissertation nearing completion, my focus is turned to the future of this project. The entirety of Medinet Habu has now been entered into the database, and over the next several months I plan to record a number of other monuments, beginning with other Ramesside material. It is my aim to produce a version of the database that can be made available online for other scholars to utilize for their own research. With this shared online version, I hope to enlist other scholars in the data entry process. If you are working on material that hasn't yet been entered into the database, but would like to utilize this method, it will be possible for you to enter your own images so that they may be efficiently searched, compared to the larger dataset, and quantifiably analyzed. With enough collaboration, the size of the database could grow exponentially, with great benefit to all. With sufficient data, amazing patterns can be noted. Insurance companies have been collecting immense amounts of data on the population for centuries. Now, through the strength of their data and using predictive modeling, they are able to indicate with remarkable accuracy the number of people who will die in a given period from a particular illness. Predictive modeling holds immense potential for Egyptology and art history as well. When enough data have been acquired, it will be possible to fill in the gaps in a damaged relief with a degree of certainty based on other examples. Similarly, when the database is large enough, it may be possible to identify the likely original location of a relief fragment within a structure based on the attributes that appear on it. Any monument or object type can be transformed into a dataset, and this method has the ability to instantly reveal multiple patterns. Rather than examining the group of 5 interrelated attributes focused on in the case study, I could instead have investigated any of the numerous intriguing usage patterns indicated by the correlation analysis. Additionally, some of the more complex methods, such as factor analysis, showed a number of suggestive groupings. This methodology is basically a discovery generator, capable of bringing to light many notable usage patterns within a dataset in an instant. Rather than randomly choosing a group of elements to investigate, spending vast amounts of time identifying their occurrences and then studying those instances in the hopes that they prove meaningful, this process allows a researcher to select from a number of quantifiably significant patterns the one which interests them the most, and proceed from there. Thank you so much for your time and support.